I'm Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we will learn about trigonometric identities. We'll begin with understanding what are quotient identities, how do we relate the reciprocal identities, how do we prove the Pythagorean trigonometric identities, understand the cofunction identity, and what are even and odd functions. We are then going to use these identities to prove many more identities. You will learn multiple strategies to understand all these concepts. Our approach, engaging minds, connects with context. We help you to visualize strategies, apply the learnings, and bridge the gap. Creative thinking and problem solving is key to our teachings. Our approach, engaging minds, help you to develop mathematical and social skills. You gain confidence and you will be ready for the future. In case you want to learn from me, you can always send an email on the address given. I can be part of your success story, build strong foundation, and ensure bright future. It is a gift of education. Let us now enjoy the lesson with the student Rohan. Hi Rohan, how are you doing?
I'm good, sir. How are you?
Very good, very good. So how did you perform in grade 10?
Overall, sir, I performed pretty well. I was able to understand like the whatever I needed to learn for grade 10, and I feel like I have a basic understanding of what I might have to learn in grade 11. So with the basic concepts of my previous math lesson.
So what was your percentage marks in grade 10?
I
Mathematics.
think it was mathematics, what I remember, because it was a long time ago. It was somewhere in the 90s, late high 90s, mainly very close to 100.
Very good, very good. So again, this time in grade 11, you should score very close to 100. So that is how it should be. So MCR3U is the course which you're going to follow. And now, today, we'll touch upon basics on trigonometric identities. Okay? We have already covered some basics about trigonometry. Today, we'll do in details trigonometric identities. Perfect? Let me share with you a whiteboard giving you a few concepts, and then we'll take up examples in a sequence that should help you to develop an approach to prove an identity. Okay? So we are basically focusing on trigonometric identities. Let me write in short, trig identities. So normally, you work with equations, right? For example, you have an equation. So before getting into identities, let's also try to understand what are trig equations. Well, generally, let's also understand two other terms, which is what is the difference between equations and identities? Can you tell me what is the difference between an equation and an identity?
Isn't an equation like a word, like a problem? It can be any sort of problem, like a word problem, for an example.
And how about identity?
Identities would be like what a value represents.
Okay, so let us say there is an equation. Equation will have equal to sign, correct?
Yeah.
Something on the left hand side and
something on the right.
Right? And this is true for some values. It may be true for some values. Is it okay?
Okay, sir.
For example, you have an equation 2x plus 5 equals to, let's say, 15. Let's keep it simple. So when you solve this equation, you will say 2x equals to 15 minus 5, which is 10. And so x is 10 over 2, correct? So this equation is true for one value, which is 5, correct?
Yes, sir.
I have an equation which is x squared plus 1 is equal to, let us say, 5. In that case, x will be equal to what? Well, x squared will be 5 minus 1, which is 4, and x will be plus minus square root of 4, which is plus minus 2, correct? This equation is true for two values, correct? But
Yeah.
not all the values. So these are equations which are true for some values. Some equations may not be true for any value, correct? For example, if
Yeah.
x squared plus 1 equals to 0, it has no solution, correct?
Yes, sir.
So equations may or may not have solutions, but they have limited number of solutions, correct?
Yeah.
Now, when we talk about identities, in that case, identities are true for all values in their domain. In their domain means all valid values of x. You get the idea. Well, to give an example, if I say, what is x squared minus y squared? You say, well, x squared minus y squared is x plus 1 times x minus y. Now, this is an identity. You get the idea. It is true for all the values of x and y, correct? Now, here, left-hand side is always equal to right-hand side for both x and y belonging to any real number. You get the idea?
Yes,
So
sir.
identities are true for each and every value in the domain of the variable, correct? Is that part clear?
Yeah.
Perfect.
Yes, sir.
Now, let's look into some identities and some equations first, and then we'll see how do we prove identities. Is this all part clear? I'll erase it then. Perfect.
Yes, sir. I got it.
Trigonometric equations and trigonometric identities. So we learned that the ratio sine theta over cos theta is equal to what?
It would be equal to
Tan
tan.
Now this is an identity. It is true for theta belonging to real number. This means theta belongs to real number. Any real number theta could have, correct?
Yes, sir.
Right. But here we have a restriction that we cannot divide by 0, right? We cannot divide by 0. So all the values for cos, which gives you 0, those values theta cannot have, right? So we say theta belongs, let me rewrite this, for theta belongs to real numbers, where what value of cos could be 0? Cos of 90, cos of 270, all odd multiples of 90, right? So theta,
Yeah, 92, 70, 360.
yeah, 2n plus 1 into 90 degrees. You understand?
Yes, sir.
Because that will make cos theta 0. So that becomes a restriction in the domain. And this is a restriction of sine theta over cos theta. You cannot divide by 0. You get the idea?
Yeah.
So that is the restriction. Cos theta is not equal to 0. And therefore, we have a restriction that theta is not equal to 2n plus 1 or odd multiples of 90 degrees. You get the idea?
Yes, sir.
Because if I put 90 degrees here, then the sine theta of sine 90 is 1 divided by 0, which is meaningless. Okay? So therefore,
Yeah.
to be understood that whenever we are talking about identity, we are talking about all the values in the domain of the equation. Is it okay? So in general, this is an equation, correct?
Yes, sir.
Equation which is true for all theta in domain. Because theta cannot be 0 for sine theta over cos. Theta cannot be odd multiple of 90 degrees cosine. You understand this?
Yeah.
Correct? So that is an identity. Correct? Now, let me give you another example, which is like, okay, I'll go the other way. We'll prove some identities. This is our first identity, which is ratio of sine theta and cos theta is tan theta. Make a note of it.
Done,
Now,
sir.
okay, so we had earlier learned that if I have any point in coordinate plane, so I'm just reviewing few concepts with you quickly, P, which is value of x and y, it really means that the x coordinate means 0 to, if I drop a perpendicular here, let's say at, in that case, PQ will be y and OQ will be x, right? Because the coordinate.
Yeah.
If the angle here is theta, we know what sine theta is, right?
Yeah. Opposite over adjacent.
OP is R, let us say. OP is R, which is a constant. In that case, sine theta over hypotenuse, right? So let me write.
Yeah.
So I'll write sine is opposite over hypotenuse, cos is adjacent.
Adjacent over hypotenuse and tan is opposite over adjacent.
Right. So sine theta is equal to y over r. Cos theta is over r and tan is equal to
X over R and tan theta would be
y
y over X.
correct? So we can
Yeah.
put our ratio identity sine over cos. So if I write, look here, tan theta is y over x, right? So let me prove the first identity, which is, we are saying tan theta equals to y over x, right? So let me rewrite like this. It'll be better for us to understand. So we can divide both by r, right? Y over x. So what is y over r? Y over r is sine theta.
Is sine. And then X over R is cosine.
Cosine theta, right? So
Yeah.
over cosine theta, tan theta, we have shown the first identity, which is the ratio identity.
Yes, sir.
Okay. Now, from here, we'll actually prove three more identities, which are very, very useful. Let's use the Pythagorean theorem. You remember Pythagorean theorem?
Yeah. A squared plus B squared equals C squared.
Okay. So in this particular case, since we have x and y, so we have x squared plus y squared equals to r squared. Is that clear to you?
Yeah.
If I divide everything by r squared, what do I get?
You would get cosine plus, oh wait, no, you get
Cos
a
squared
secant plus secant.
equals to tan squared theta, right?
Oh, okay.
Oh, equals, sorry, 1 equals to 1. Sorry. R square is 1. R square divided by.
Yeah.
So sine square theta plus cos square theta, we got the first identity. Let me rewrite this as equals to 1, correct?
Yes, sir.
Now, let me redo this calculation by dividing with a different number. So I'm using a different thing. We have x squared plus y squared equals to r squared. This is Pythagorean theorem, right? Let me divide everything by x squared now. So x squared divided by x squared is 1. Y over x is what? Tan, right? Equals to r over x, which is secant square theta.
Plus secant squared theta, right, sir?
So we know from here reciprocal identities. Let me write down. Cot theta will be x over y.
X over y.
Secant theta.
Secant would be r over x, and cosecant is r over y.
Correct. So we got the second identity, which is, let me now circle these since I utilize the above space. Identity number 1. This is identity number 2. Correct. Okay, let's create another identity. Starting from x squared plus y squared equals to r squared. If I this time divide by y squared, what happens? Tell me.
If you divide it by y squared, sir, would it be
X over y is what? X over y is cotangent
Tangent
square theta
theta plus 1
and
equals
by
to
square.
cosecant square theta.
Correct. So we get the third idea. Did you see how using Pythagorean theorem, right?
Yeah.
We got identities. Do you see that?
Yeah.
3 of them. These are very, very important identities which will be used in proving identities, which is our main topic for today, correct?
Yes, sir.
Make a note of this. I'll rewrite these Pythagorean identities on a fresh page and we'll continue from there. So we call these as trigonometric Pythagorean identities. So as first one which we found was sine square theta plus cos square theta equals to 1. The second one was
Sin square theta plus
1
cos square theta
secant,
equals to
and then
1 plus tan square theta equals to secant square theta, and cotangent square theta plus 1 equals to cosecant square theta.
correct. So we got 3 identities right there. Do you see them?
Yes, sir.
So for us, the first identity was the ratio sine theta over cos theta and tan theta, and 3 more. So 4 identities we have covered. Now let us see in different type of questions, how do we apply these basic identities to prove more identities? That's the whole strategy. Now, let's look into the very first identity, which is sine square theta plus cos square theta equals to 1. I can always write this as sine square theta equals to 1 minus cos square theta, correct?
Yes, sir.
So that becomes a related identity. I could also write this as what? Sine square theta equals to, this is difference of square. You remember a square minus b square is what? A plus b times a minus b, right?
Yes, sir.
And therefore, I could write this as 1 plus cos theta times 1 minus cos theta, correct?
Yeah.
So sine square theta can be written as 1 plus cos theta times 1 minus cos theta. So, and similarly, you could write cos square theta as what? That's right, cos square. Cos square theta will be 1 minus sine square theta, right? It could be written as 1 plus sine theta times 1 minus sine theta, correct? So what we have done in this particular case is that from the Pythagorean identity sine square theta plus cos square theta equals to 1, we have shown more identities. You see different ways of writing sine square, cos square in terms of this.
Yes, sir.
Now here's the question for you. So cos square theta, you know, is 1 minus sine square theta, correct?
Yeah.
And this is an identity. Always true.
Yeah.
I'll give you an equation that cos theta is equal to, because cos square theta is 1 minus sine square theta. If I write theta equals to square root of 1 minus sine square theta. Will this be an identity?
So the equation is cos
Cos
theta is
square
equal
root of 1
to,
minus sine square theta. Is this equation an identity?
wouldn't it wouldn't be an identity, it would be more of an equation, sir, because there can be more than one and it's not always true.
No, because cos theta can be positive or negative. So I have to write positive and negative here to make it an identity. You get the idea?
Yeah.
If I do not write positive and negative, then it is an equation. It is always not always true. Is it okay?
Yeah.
Because cos is going to be positive in quadrant 1 and 4. So that will be only possible in quadrant 1 and 4, right?
Yeah.
So remember the cos rule. Only if you do plus and minus, then it is an identity, otherwise not. Very important point to remember. You get the idea?
Yes, sir.
Okay. So we have seen how do we work with sine and cosine. So sine square theta plus cos square theta equals to 1 can be written in many different ways, and this strategy can help us in proving many equations, correct?
Yeah.
Okay, now let's look into the second Pythagorean identity, 1 plus tan square theta equals to secant square theta. Now, I could write this as 1 equals to secant square theta minus tan square theta. Rearranging this into a particular value, and therefore, we also write this as 1 as equal to secant theta plus tan theta times secant theta minus tan theta, correct?
Yes, sir.
We could also write this particular equation. So you see 1 plus tan square theta equals to secant square theta has been written in a different way. That will help us to prove many identities later on. Similarly, for the last equation, 1 plus cot square theta equals to cosecant square theta, we can write 1 is equal to cosecant square theta minus cot square theta. Or we can say 1 is equal to cosecant square theta, we'll write this as sum and product. Cosecant theta plus cot theta times cosecant theta minus cot theta. You see that? So what we have done in this particular page is learn how do we use the Pythagorean trigonometric identities in different conditions. How we can rewrite them and create more identities from the given identity, correct?
Yes, sir.
Okay, now, is this all clear? We'll move on to the next type of identities, okay? Now,
Okay, sir.
we will call this as a even and odd function. Let's look into sine and cosine graph. Even function and odd function. The sine graph, if you sketch, it will be kind of like this. Something like this. Is it okay? Now, what do you notice here that sine is an odd function because these are different values of theta, right? And that is the value of sine theta. So what you notice here is that sine of minus theta is equal to sine of theta, and therefore it is an odd function.
Which is, so the equation would be sine multiplied by negative theta is equal to sine of theta.
Sine of minus theta is sine theta. Yeah, because if you just calculate what is sine of, let's say, minus 60 degrees, you'll find that this is equal to negative of sine of 60 degrees.
Oh, sir.
Because as you know from the cast rule, let me show you here. When we say sine theta, we are saying this value, right? Theta. And minus theta is this value, right? Minus means for the clockwise angle, right? And you know that the cast rule, sine is positive only in quadrant 1 and in 2. It is negative in quadrant 3. So it will give you a negative value, correct?
Yeah.
So sine of minus theta is negative of sine of theta, correct? Because it's a negative value. On the other hand,
yes, sir.
Cosine graph, let me sketch one here. Oh. So cosine graph will start with the maximum, correct? And so go to this point as a minimum, and then At this point, it is going to be maximum, right?
Yeah.
So you see it is an even function, and you know cos of minus theta is equals to cos of theta. So that is called an even function. Is it okay? Because cos is
Oh, okay.
positive here, right? So even symmetry is something like this. If you go left side and right side, you get the same value. Do you see this?
Yes, sir.
This is positive theta, that side is negative theta, correct? You see that part? So even and odd symmetry gives you these identities. So let me rewrite 1, 2, and then for tan also, tan is an odd function. Tan of minus theta is equal to tan theta. You can make a note of this also. You can see that cos root, tan is positive in quadrant 3, not in 4, correct? So
So,
if,
sir, basically, sine of negative theta is equal to sine of theta. That is an even function.
no, cos of minus theta is cos theta, that is an even function. But
Okay,
sine
so,
and tan are odd functions, okay?
okay, sir.
Yeah. Okay, now we look into more identities and we call them as co-function identities. We have seen, let me sketch a right angle triangle to explain you co-function identity. Let us say I have this right angle triangle, which is, let's say, ABC. In that case, we could label these sides as A, B, and C, right? So what is sine of A? Let's say sine, let me write. What is sine of
Sine
A?
of A, sir. That would just be A over C.
Right. But what is cos of B?
Cos of B would be A over C.
Same as sine of A, right?
Yeah.
And this angle, if this is theta, that angle will be what? This angle will be 90 minus theta, right?
Yeah.
90 degrees, correct? So what we see is sine of A is equal to cos of 90 minus A, correct?
Yes, sir.
You see that? That is the co-function identity. Because when you look from the third angle, in that case, the opposite becomes adjacent, and adjacent becomes opposite side. And the other way is also
Oh,
right.
minus.
Cos of A will be equal to sine of 90 minus A. Now let me figure out what is tan of A equals to. Tan of A will be A over B. And what is tan of B? B over A, right?
Tan of B would be, yeah, B over A.
Which is equal to 1 over tan A, right? Or cotangent A. Is that clear to you?
1 over tan A, right, sir?
Yeah, 1 over tan is cot A, correct? So what we
Yeah.
discovered is that tan of, and what is B? B is 90 minus A, right?
Yeah.
Perfect. We're taking all the angles in the discussion today. So tan of 90 minus A is cot A. Perfect.
Yeah.
What we'll do now is clear this and write co-function identities formulas. So we understood that sine of 90 minus theta is cos theta. cos of 90 minus theta will be sine theta. And tan of 90 minus theta, all in degrees, right, will be equal to cotangent. So these are function identities. Is that clear to you?
Yes, sir.
Perfect. Now, with these identities explained, I will now like to take up some examples and see how do we use how do we simplify trigonometric expressions which will help us identities later, okay?
Okay, sir.
Okay, so let me clear this. And now we'll now we will learn some skills. How do we simplify an expression before getting into identities? This is our basic preparation, how to simplify expressions. So let me give you first expression, which is 1 over 1 minus sine x plus 1 over 1 plus cos x, or sine x. Let me write 1 plus. Can you simplify this? You can take a common denominator and then simplify it, right? So we can take a common denominator, which will be 1 minus sine x times 1 plus sine x, correct? The numerator will be cross multiplied. So we get 1 plus sine x plus 1 minus sine x. And what we get here is 1 plus 1 is 2. Sine x and sine x cancel. And the denominator, we get 1 minus sine square x, correct? And 1 minus sine square x is cos square x. So we get 2 over cos square x. And we, from here, can write this as cos reciprocal is secant. So we get 2 secant square x. Do you see that? So we simplified an expression, correct? Which is 1 over 1 minus sine x plus 1 over 1 plus sine x, which is equals to this. Now, I could have given you this question as an identity also. So my question could be prove 1 over 1 minus sine x 1 over 1 plus sine x is equal to 2 secant square x. Do you see that? Prove this identity. And how will I prove it? Well, this strategy is shown here. Proving means that left-hand side is equal to right-hand side.
Right-hand side.
Strategy. So what I began, left-hand side is more complicated. So we can begin from left-hand side. The left-hand side is equal to what? Left-hand side is equal to 1 over 1 minus sine x plus 1 over 1 plus sine x. We simplify and write as this, which is right-hand side, right?
Yeah.
Left-hand side equals to right-hand side. We have proven the identity. You get the idea? So
yes, sir.
Identities basically mean simplifying expression on each side. Sometimes simplifying expression on one side can work it out, right?
Yeah.
So do you understand? I'm going the reverse way because we should understand how do we prove an identity. So if the question was kind of like that, the idea is that the left-hand side is more complicated, and therefore I will try to simplify and show it to be equal to right-hand side, just as I've done in this particular question, right?
Sir, I just have a quick question. So you know how after when we found out like what 1 over 1 minus sine of x plus 1 over 1 plus sine of x, right? And how we got the equation to be 2 over 1 minus sine square of x, right?
Yeah.
Did you use the trig Pythagorean
Yes.
equation
Yes.
to switch it into cosine to find out its reciprocal function?
Yeah. 1 minus sine square x. So we had shown earlier that sine square x plus cos square x is equal to 1, right? So we know that cos square x is equal to 1 minus sine square x, correct?
1 sine square.
So from the
Yeah.
trigonometric identity, which we showed earlier, we use this as cos square x. Do you see that?
And then secant, because it is the reciprocal function where it will be 1 over cos, we just
From
flipped
reciprocal
it the other way around, right, sir?
Yes. Perfect. You get the idea, right?
Yeah.
Now we will write down each and every step for next identity, which will be, let me take a similar example, okay? 1 plus cos x plus 1 over 1 minus cos. What is this equal to?
1 plus cos of x, sir,
Yeah, what is this? Simplify this.
plus 1 minus cos of x. That should be 1 plus cos of x plus 1 minus cos of x over 1 plus 1 minus cos of x multiplied by 1 plus cos of x, where you would get 2 over cos squared x, which would just be 2 over sine square x, which would be 2 of, so sine is cosine, sine is cosecant, so 2 cosecant square x, right, sir?
Yeah. So at this stage, you will see that when you multiply this, at this stage, you know, a plus b times a minus b is a square minus b square, right?
Yeah.
And therefore, we got that statement. 1 minus cos square x is equal to sine square x, and we substituted 1 minus cos square x as sine square x. And then we use the reciprocal identity, right?
Yeah.
And then reciprocal identity, because we know that 1 over sine x is cosecant.
Yeah.
That is how we showed this. So if you have a question, which is what is 1 over 1 plus cos x plus 1 over 1 minus cos x equals to 2 cosecant square x. So this is an identity, correct?
Yes, sir.
You can prove this identity by going from left to right.
Yeah.
The simplifying expression is a method of proving identities. And therefore, I want to put it the other way. That is, let us understand, how do we simplify an expression? Correct?
Yeah.
Great. We'll take up another very important expression which helps us to prove identity. This time, we have this equation, which is square root of 1 plus cos x over 1 minus cos x. How do you simplify this trigonometric expression? Tell me.
So 1 plus cos x over 1 minus cos of x.
Yes.
Would it be square root of 1 plus cos of x plus 1 minus cos of x over in brackets 1 minus
So what we
cos.
do in this particular case is to rationalize the denominator. Rationalize denominator.
Oh,
It means multiply by the conjugate of denominator. So we'll multiply numerator by 1 plus cos x and denominator also by 1 plus cos x. Dividing and multiplying by the same term means multiplying by 1, which is not going to change the equation, right? Equation is still the same. And now you can expand this. So the numerator becomes 1 plus cos x, whole square root means 1 plus cos x, and the denominator is 1 plus cos x times 1 minus cos x, means 1 minus cos square x. Square root, correct?
Yeah.
Now remember one thing, that this expression is always positive. Correct? Because square root of anything, if you do it like this, is always a positive number, right?
Yeah.
And therefore, we normally write absolute value here, saying that this is always positive. You understand?
Yes, sir.
So now, we have 1 plus cos x, 1 plus cos x in the numerator, and the denominator is square root of 1 minus cos square x.
Square.
Square root of sin square x, correct?
Yeah.
And that is a positive value. So we have 1 plus cos x over absolute value of sin x. You get the answer, right? You understand?
Yes, sir.
Can you explain me this particular step? Square root of sin square x is absolute value of sin x.
Is it because of how sine x and square root cancel each other out?
Okay,
And
so what is square root of x squared equals to?
x.
No, it is absolute value of x.
Absolute value.
Because square root is always positive. So it is not x. X could be negative, right?
Oh,
So therefore, we should write this as absolute value of sin x. You get the idea?
yes, sir.
Always this has to be a positive number. We could actually continue. We got 1 plus cos x. Let me rewrite on the next page, or we can write it here itself. We just showed that square root of 1 plus cos x over 1 minus cos x equal to 1 over sin x, right?
Yeah.
Plus cos x over sin x, correct?
Yeah.
All positive, right? Absolute value.
Oh,
Answer has to be positive, correct?
yeah.
So 1 over sin x is cosecant x, and cos x over sin is cotangent x, right? We could write this as cosecant x absolute value plus cot x absolute value.
Okay, sir.
That is how to use rationalization of the technique to prove identities. Is that clear to you?
Yes, sir.
Now, let's have a question for identity. So here is a question for you. I'd like you to try this out. So 1 minus cos theta over sin theta is equal to sin theta over 1 plus cos theta. Prove this identity.
Sine theta over 1 plus cos theta.
How will you prove this identity? Tell me. First thing is, we should decide from which side to start. In this case, we can start from left or right, correct? So let's start
Yeah.
left-hand side. So we say left-hand side is 1 minus cos theta over sin, correct? Now clearly, what we really need is sin theta on the top, right?
Yeah.
And 1 plus cos theta in the denominator. How can we get that? So what we could do is, tell me, do you have any idea?
1 minus cos of theta over sine.
So we could multiply by the conjugate of 1 minus cos theta, which is 1 plus cos theta. Do you understand?
Yeah, 1. Yes, sir.
What we'll do is we'll rationalize numerator. That is to say, we'll multiply by 1 plus cos theta and divide by 1 plus cos theta. So we get in the numerator a plus b times a minus b, right?
Yeah.
Which is 1 minus cos square theta. And the denominator will be sine theta times 1 plus cos theta. So here we know that a plus b times a minus b is equal to a square minus b square. Now remember, never expand denominator. Note. Okay, whenever you rationalize, never expand denominator. Now, if we continue with this, what is 1 minus cos square theta? Tell me.
1 minus cos squared theta divided by sine square brackets 1 plus cos squared theta.
Square theta, right? Trigonometric identity.
Yeah.
Right? And the denominator is sine theta 1 plus cos theta. So you can clearly see that one of the sine thetas cancel. So we're left with what? We're left with
1
over 1 plus cos theta.
Yeah.
Which is the right hand side. So we've shown that left hand side is equal to. Is that clear to you?
Yes, sir.
So that is how we could actually prove the identity.
Okay, sir.
So with the techniques learned today, I think it'd be very easy for you to prove many identities. You can actually look into your questions from the book, solve them, and I hope you'll be able to solve or rather prove many identities or solve many questions from your book. In case there is any difficulty, we can always look into those. Is that okay?
Okay, sir. So question number 8 is prove each identity, state any restrictions on the variable. So the equation, so I'm just gonna do equation C, sir. So equation C is cos squared x is equal to 1 in brackets 1 minus sine of x, close brackets, multiplied by 1 plus sine of x.
So that is simple, we did, right?
Yeah.
You can start from right hand side. So you get difference of squares, which is cos square x. Correct? Easy?
Yeah.
Okay, so you did 8c. Why? Let's start with 8a. So what is 8a?
I don't know the symbol of it, but
It means
pi, sir?
5. So it is sine squared phi
over 1 minus cos phi equal to 1 plus cos phi.
How will you do this?
We would first solve from the left side, sir.
Okay, so let's do this. You can start from the left hand side. So left hand side in this case is sine squared phi. This is phi, okay? Greek symbol. 1 minus cos phi sine square phi. And what is sine square phi equals to? Sine square phi is 1 minus cos square
1 minus cos square pi.
Phi, right? And then we have denominator 1 minus
Cos of phi.
Now 1 minus cos square phi can be written as product of sum and difference, right?
Yeah.
And you can clearly see that 1 minus cos phi cancels and you're left with what? You're left with 1 plus cos phi, right?
Yeah.
Which is right hand side. So you've shown that left hand side is equals to right hand side. Do you see how easy it is?
Yes, sir.
Perfect. So that is how you're going to do it, right? In the first question, it was very simple. You could start it with right hand side, right?
Yeah.
Well, that seems to be more complicated. And you know, sum of sum and difference, product of sum and difference, right?
Yes, sir.
Will be what? Will be 1 minus sine square x which is cos squared x, correct?
Cos square x. Yes, sir.
Left-hand side. So sometimes you can start with left-hand side, sometimes with right-hand side. Look for the part which is more complicated. So simplify the complicated part, make it simpler, and prove it to be equal to the other side. Okay?
Yes, sir.
That is how you do that. So I hope by now you have understood all the concepts and you will be in a position to answer all the questions in your book. Whatever are the difficulties we can look into. Okay, WhatsApp me or email me your difficulties. Perfect.
Okay, sir.
Okay, so we'll end our class at this stage. Will you like to summarize today's learnings?
So far in today's class, we learned like what are trigonometric identities, like the trigonometric functions, the primary and the reciprocal versions of theirs. Understanding what an equation and an identity is,
Yes.
and how we can solve back and forth between each other.
Yes.
And then we went on to learn about the formulas of the Pythagorean identities and how we can go back and forth with the different primary and reciprocal formulas from like sine to cosecant, etc.
Yes.
Understanding like what an even function and an odd function were, like how sine of a negative theta is equal to sine of theta, and along with that, like co-function identities, and how, for an example, we were able to understand like how cosine would be 90 minus theta, which would be sine theta.
Correct.
And then in general, like using all the knowledge from there to help simplify expressions.
Very good. So let me share with you to end the class the formula list. Okay. So here is a formula list which you can see. You see this shaded in green. So
Yes.
first we learned the quotient identity, which is what tan theta is equal to, right? Tan theta is ratio of sine or cosine. Cotangent, which is reciprocal of tan, becomes cos over sine theta, right?
Yeah.
We also know all our reciprocal identities. Cosecant is 1 over sine theta, secant theta is 1 over cos theta, cotangent theta is 1 over tan theta. Then we derived Pythagorean identities. Sine square theta plus cos square theta is 1. 1 plus tan square theta is secant square theta. 1 plus cotangent square theta is cosecant square theta. We
along with rearranging it, right, sir?
Yeah, along with rearranging it. Perfect. Then we also looked into odd and even identities. Sine and tan are odd functions, right? So,
Yeah.
so this is positive. Sine of minus theta is minus sine theta, tan of minus theta is minus tan theta. However, cos of minus theta is plus cos theta, right?
Yeah.
Then we also looked into the coordinate plane with r and theta. So in that case, if the value for a point in this particular example has been taken as a and b, right? So point P has been taken as a and b, and this is r. So in that case, we could write these ratios in terms of the coordinates, right? And
yes,
these
sir.
are the co-function identities which you were saying, sine of 90 minus theta equals to cos theta. So in a triangle, 90 minus theta, in right angle triangle, 90 minus theta is looking from the other side. And that helps us to equate sine with cosine, tan with cotangent, correct?
Yes, sir.
Now here are a set of questions which could be your practice test questions. So let this be your practice test questions, okay? So these 5 questions are for you to do. You can take a screenshot. I'll share this video also, but for now, you can take a screenshot of this and then solve them. And if you have any difficulties, let me know. Use the strategies which you have learned today. Perfect?
Okay, sir.
Okay, great. So we can end the class at this stage. And I hope all these concepts are absolutely clear. Feel free to contact me in case there is any difficulty. Okay?
Okay, sir.
Okay then. Bye for now.
Goodbye, sir.
Thank you.